Hey guys, welcome back to another School video. Today our lesson is CBSE 7th grade math, chapter 1 integers. This is a part 1 video where we'll be discussing 1.1, 1.2, and 1.3 of this chapter. Hope you guys enjoy and stay tuned for more School. So right off the bat, what are integers and what is an integer? Integers are basically a collection of whole and negative numbers. Another way to think of integers is whole numbers plus negative numbers is equal to integers. An integer is basically a whole or negative number. Either one, it'll still be considered as an integer because an integer is basically whole numbers plus negative numbers. So for example, the number 74. It's a whole number, but it'll be considered as an integer because whole numbers are what integers are consisted of. A negative 43 is also an integer because negative 43 is a negative number and negative numbers are integers. The perfect way to basically describe the collection of integers is on a number line. On number line, as you can see here, we see whole numbers and negative numbers. All of these numbers will be integers and each one of these numbers will be considered as an integer. The number 0 gets most people confused, but the number 0 is an integer in case you're wondering. And that's because the number 0 is a whole number. Whole numbers are integers, and whole numbers are numbers 0 through infinity. As you can see here, 0 is a whole number. The reason people don't think that 0 is an integer is because the number 0 is neither positive or neither negative. That's an important point to note down. So now I'll teach you guys how to add and subtract integers on a number line. In your previous grades, you probably learned how to add and subtract integers, but not on a number line. So I'll be teaching you guys how to add and subtract integers on a number line. So first, how to add integers on a number line. What exactly is adding? Adding is increasing a number. On a number line, when we move to the right, the numbers begin to increase. Because of this, when we add integers, we move to the right. Here's the actual process of adding integers on a number line. You should note this down. I'll be giving you guys a few examples and I'll explain this process while we do the examples. Next, how to subtract integers on a number line. What is subtracting? Subtracting is basically decreasing a number, right? For example, if you're doing 5 minus 2, you're basically decreasing 5 by 2. So subtraction is decreasing a number. As we move to the left of a number line, the numbers begin to decrease. So that basically means that if you're subtracting integers, we move to the left. Here's the actual process of subtracting integers on a number line. Note this down by pausing the video. I'll be explaining this process while we do some examples. There's some important points to note down as well. When you're adding integers on a number line, you move to the right, or in other words, as we move to the right of a number line, the numbers begin to increase. When we subtract, we move to the left, or in other words, as we move to the left of a number line, the numbers begin to decrease. So now I'll be giving you guys a couple of examples of adding integers on a number line. Our equation is negative 5 plus 8. The first step of adding integers on a number line is to basically plot the number you're adding from. In this equation, negative 5 plus 8, the number you're adding from is 5. So we plot the number 5 in the number line. So next, since we're adding, we're increasing the numbers, right? So that basically means that we move to the right. As we move to the right, from negative 5, we move to the right. We basically increase the number by moving to the right by the number you're adding by. So the number you're adding by in this equation is 8. So we moved 8 to the right. We moved to the right because the numbers are increasing. And increasing a number is basically adding. So to add from negative 5, we move to the right 8 times. So we move from negative 5 to negative 4, which is a right turn, and so on until we do 8 right turns, which leads us to the number positive 3, which is our answer. So next, I'll give you guys an example of subtracting integers on a number line. The equation we have here is negative 1 minus 4. So the process of subtracting integers on a number line is first you plot the number you're adding from, which in this case is negative 1. So from negative 1, that's the second step, we move to the left, because subtraction is decreasing the number, and decreasing a number is basically moving to the left. We move to the left by the number you're adding by. In this equation, the number we're adding by is 4. So from -1, we moved 4 to the right because we're basically decreasing by 4. So we move 4 to the right. And that, we move 4 to the left, sorry. And that leads us to -5. So -5 is the answer. -1 minus 4 is -5. So now hopefully you've learned and mastered how to add and subtract integers on a number line. Now let's discuss the properties of integers when you're adding and subtracting. Our first property is the closure property of addition of integers. This property states that all integers are closed under addition. What do we mean by this? Well, suppose we're doing 5 plus 6. The numbers 5 plus 6 are both integers, right? 5 plus 6 is equal to 11. 11 is also an integer. So that's cool. Here we notice that an integer plus an integer is equal to an integer. So, can we say that an integer plus an integer always equals an integer? Well, let's try to prove that by doing another example. Let's suppose we're doing -7 plus 5. -7 and 5 are both integers, and by adding both of these integers, we get -2, which is also an integer. So we can state that an integer plus an integer always equals an integer, and that's basically the closure property. By stating that an integer plus an integer always equals to an integer, that's stating that all integers are closed under addition, which is the closure property. The property that states that all integers are closed under subtraction. This means that an integer plus an integer always equals an integer. So now let's learn about the closure property of subtraction of integers. So this property states that all integers are closed under subtraction. What do I mean by this? Let's just do a couple of examples. So this is sort of like the closure property of addition of subtraction. When we subtract two integers, the answer is equal to an integer. And even if we do another example, by subtracting two integers, we always get an integer. So this basically means that all integers are closed under subtraction, which is the closure property. Or in other words, an integer minus an integer always equals an integer. That's the closure property of subtraction of integers. All integers are closed under subtraction, or in other words, an integer plus an integer always equals an integer. So now let's learn about the commutative property of addition of integers. This property states that no matter what order you add the integers of an equation, you get the same sum. What do I mean by this? Suppose you're doing 2 plus 7. 2 plus 7 is equal to 9, right? So let's swap the numbers. Let's swap the numbers in this equation. We change the position. We swap the order of the numbers so that now they're in a different order. So from 2 plus 7, we change it to 7 plus 2. 7 plus 2 is equal to 9. As you can see here, in both of the equations, we changed the order. We went from 2 plus 7 to 7 plus 2. We swapped the numbers. We changed the order. Even though we changed the order, both of the equations have the same sum of 9. That's the commutative property. The property that states that no matter what order you add the integers of an equation, you get the same sum. Or basically, even if you swap the numbers of an addition equation, you get the same answer, as we saw over here. So due to this property, we can state that addition of integers is commutative. Is there a commutative property of subtraction of integers? Well, the answer is no. Subtraction of integers is not commutative. Why? Well, suppose you're doing 7 minus -2. 7 minus -2 is equal to 9. So let's swap the numbers of this equation. To make it -2 minus 7, we swap the numbers as you can see here. By doing -2 minus 7, we get -9. So even though we swapped the numbers of both of these subtraction equations, the numbers of the subtraction equation, even though we swapped the numbers, the answer is not the same. For example, in the first equation we got -9, and then we got 9. We got +9. The differences aren't the same, so that's why we can say that subtraction of integers is not commutative. So that means that in conclusion, the commutative property of subtraction does not exist. Next property is the associative property of addition of integers. This property states that no matter what order you group the integers of an addition equation, the sum will be the same. What do I mean by this? Suppose you're doing 5 plus -6 plus 7. How do we solve this equation? Well, first we solve whatever is in the parentheses. By solving the equation in the parentheses, we get 1. So now we do 5 plus 1, which is 6. So the answer to this equation is 6. So now let's change the grouping of the numbers. So in this equation, we have 5 plus, in parentheses, negative 6 plus 7. The numbers inside the parentheses are negative 6 and 7. Well, let's change the groupings. Let's change the grouping, or in other words, changing the position of the parentheses, which basically means the numbers inside the parentheses will change. So let's make the parentheses over here. Let's make the parentheses be negative. Let's have the numbers in the parentheses be negative 6 and 5. So that'll make our equation negative 5 plus negative 6. We've sort of changed the parentheses, as you can see here. So in parentheses, by changing the grouping of the equation, we get a new equation of 5 plus negative 6 plus 7. By the way, 5 plus negative 6 is in parentheses. So let's try to solve this. 5 plus negative 6 is negative 1. Negative 1 plus 7 is equal to 6. In both of the equations, though we change the grouping, or we basically change the position of the parentheses, we get the same answer of 6. So what does that mean? It means that addition of integers is associative. By the way, there is not an associative property of subtraction of integers, because if you change the groupings, or if you change the position of the parentheses of a subtraction equation with integers, the answer will not be the same. For example, for this example I have here, for the first equation has a difference of 4, while the second one has a difference of 18. Because the differences are different, this proves that subtraction of integers is not commutative. Or in other words, by changing the groupings of a subtraction equation, you won't get the same answer. The associative property of subtraction of integers does not exist. The last property is the additive identity. This property states that 0 is the additive identity for integers, so adding 0 to any integer will give you the same integer. This property states that adding 0 to any integer will give you the same integer. So if we add an integer plus 0, we'll get the same integer, or basically the identity will stay the same. Let's see that. Let's say we do 88 plus 0. If we do 88 plus 0, we get an answer of 88. The identity changed. The identity of 88, by adding it to 0, we get the same answer, that its identity changes. What does that mean? It means that 0 is the additive identity for integers. What that means is that whenever you add an integer plus 0, the identity stays the same. So that's about it. Hope you guys enjoy, and stay tuned for more up-school videos. Subscribe, don't forget to hit the notifications button. Check out some of our other videos. And remember, greatness starts here. Don't stop learning, even if there's a pandemic going on. Once again, hope you guys enjoy. Stay tuned for more up-school. This is up-school. Greatness starts here. Signing off. Peace.